Hello guys, and welcome to another video on Microbit Pomodoro project. In last video we created a feature to display LEDs according to the time that is left for our timer, and now we want to improve on this in a way to animate the last active LED to blink each second on and off. So let's create a new variable. Let's call it active LED. And let's take set block, and we want to set active LED to, I will first implement it and then I will explain what exactly it does. So we have timer variable. We want to divide timer by total time. Yeah, actually you cannot search for variables in here. I thought that you can, but we'll take total time. And we want to multiply this by 25. 25 is the number of LEDs that we have, and timer over total time will give us the percentage. So it is a number between 0 and 1. And if we multiply it by 25, we will get some fraction of this in this range from 0 to 25. But in order to have active LED as an integer number, we need to remove the decimal part. So we will take, let's take not this one, but we need to take floor, and we can search for it. So if we floor all of this, it will just discard the decimal part. And we can put this block right below this if condition, and we have active LED. What is the next step is to do something different in this should plot function depending on the active LED. And let's take this if block, and we can check if so we need a comparison. So I will take this one, and if active LED is equal to LED index, because remember that we already calculated what is the LED index. So we have a number from 0 to 24 for LEDs. And if this is the case, we are going to do something different than before, but in all other cases, we are just simply going to, we simply need to return this check if timer is greater than LED minimum active time. What we need is to create a new variable, because we need to alternate the state, and we can simply call it blink. In function block, we can simply return blink, and let's take it from here, from variables, and we need to set blink to some value. So we can first set blink to, let me take from here, set blink to, and we can go to logic, and we can use not operator, and we can take the blink itself. Okay, so if we are taking a look at the active LED, it will take blink, it will set it to its in inverted state, so from true to false, and from false to true, and it will return this blink. So we already see that this is working, but I wanted to further explain how exactly is this working, and to do that I would like to switch to this Desmos site, and it has a nice tool for printing out the graphs. Let's start with defining total so we have a total time, and let's start with 20. I will explain why I'm starting with 20 and not with 25. It's simply because 25 is a special case, and you will see later on that it makes sense. We can print out x, and we can limit it to be between 0 and t. And if we zoom it out a little bit, we see that it goes from 0 to 25. If I move this slider up and left and right, it will go, it will follow this slider. Okay, now what we did? We did timer over total time. In this tool, it is actually going to be x over t, and we also need to limit this one between 0 and t. And as I said, it is going to give us a fraction between, so it is going from 0 all the way to 1. And it's perfectly natural because it is just a ratio between the current value of the x and the total value that we need to consider. And we said that we also have 25 LEDs. So if I say 25 times this fraction, it will go from 0 all the way to 25 following this total time that we have. Now it will be obvious if I move this total from 2 all the way to 25 that these two functions will overlap. If I go all the way back to 5, this function is growing much faster because the fraction goes much higher with x going from 0 to 5. Let's move this back to 20. And the last step was to discard the decimal part using the floor function, which has the same name here in Desmos as well. And now we can see that we have some discrete values in certain ranges. And we have from 0 all the way to 24. And we don't have 25 because we don't include t into this range. But if we wanted to do that, we can simply say greater than or equal, and it should give us the 25. As you can see, if I slide all the way to the right, it will give us 25. If I remove this equals, it will not go over 24. Okay. Now, if we move the slider all the way to the right, we can see exactly what we hoped for, and that is that each minute is going to be covered by a single LED. So from 25th minute, or in other words, from start of the timer all the way to the 24th minute, we see that only that the active LED will be the one with index 24. Then it goes to index 23, and so on and so on, until we go all the way below 1 minute. It will be the first LED will be the active one for our blinking functionality. If we go all the way back to 5 minutes for our total time, we see that much less time is used on a single LED. But if you do the math, you can come up to the value that, because 5 is 5 times less than 25, it means that 5 LEDs should fit into 1 minute. And this is exactly what we have in here. So if we zoom in a little bit, we can see that it's maybe easier to see it in here. So if we go from 0 to 1, we see that we have 1, 2, 3, 4, 5 active LEDs. Let's go back to our Pomodoro timer, and I want to show you one thing that needs to be fixed, because this all look nice, but there is one flaw, and we'll see what it is about. But first I need to change work time so I can show it more easily what is happening exactly. So instead of taking 60 seconds for each LED to be the active one, let's lower this down to maybe 10. And if I start now our Pomodoro timer, you will see that it will blink and it will go on and off. It should go for 10 times and then it should switch to the next one. Now, you see how it didn't actually continue this pattern of blinking, but rather it stopped for 1 second. And this is a problem because when we are transitioning from one active LED to the other one, we do not consider that we also need to reset the blink variable, because switching, transitioning from one active LED to the other one is blinking itself. Let's take a look at the work phase, and especially at this transition period. So the current time is 24 minutes exactly, and the blink value is set to true. Active LED index is 24 or the last LED. Now we know that blink is going to change from true to false, and in the next tick it will go to false. Current time will drop for 1 second, which means that active LED will move to the left, and the active LED index will be 23. What does it mean? Is that this LED will no longer be turned on, and this LED will have the new blink value of false. So let's see how it's working. And this is something that we want to avoid. This is the example of the work phase. Now let's see the example for the break phase, because here we have a different situation, and it's the transition period where the blink value is set to false, and in the next tick the active LED will move to the left with the new blink value set to true. This time it looks like our Pomodoro timer didn't work for 1 second, like it make a longer pause, but in reality the blink value should be set to false. And to fix this, it's fairly easy. We need to keep track of the last active LED, and let's create a new variable, call it last active LED, and we want to set last active LED to active LED, because we first calculate it and then we set it to this one. Now we need to check here if we transitioned from one active LED to another one. So we have a comparison operator and we see if active LED is different than last active LED. We want to flip our blink variable once more. And let's do that by setting set blink to, actually I could copy this and just remove it from here and put this in place. We have a warning. Okay, it is gone. Now let's see how it behaves. We had 5 seconds and let's see. Now it looks much better. Now we have a smooth transition and LEDs are blinking just as we would like them to blink. Now, because we have the odd value, let's now check also for the even value. So I will put 10 again. And let's see. After 10 seconds, we should see that we have a smoother transition than before. Okay, that seems to work. And that's all for this video. Thank you for watching. I hope you enjoyed this and see you in the next one. Bye bye.